So this is a lesson about quadratic equations solving by factoring. So this is Unit 3, Lesson 2. A quadratic equation typically looks like this: ax squared plus bx plus c equals 0. And having it all equal 0 is important. And the steps that we're going to follow today is take this equation and factor it by all our different factoring methods, and then set each factor equal to 0. So I'm going to go through a bunch of examples here that come right from your homework. So these are questions that I assigned in that lesson. So here's question 1e. I want you to notice that it's already factored and set equal to 0. So because it's already factored, we're just going to take each factor and set it equal to 0. The first factor is 2x plus 1. We want that to equal 0. We're going to transpose the 1. A positive over to the other side becomes negative, and then we're going to divide by 2. So there is one solution to the quadratic equation. This number will make this factor equal to 0, and if this factor is equal to 0, 0 times this factor will equal 0. That's one solution to the quadratic equation. X minus 3 equals 0, x equals 3. So if we expanded this out, it would be a quadratic equation in this form up here, and these two numbers would make it equal to 0. This is a more typical question where it's not factored yet. So this is set up like an easy trinomial. I want you to factor it using the easy trinomial method. Make sure you always write this equals 0 at the end. So what numbers multiply together to give you -6 and add together to give you -1? The numbers are -3 and +2. So I did easy trinomial on this to get these two factors. Now if these two factors multiply together to give you 0, then either x minus 3 equals 0 or x plus 2 equals 0. X equals 3, x equals -2 are the two roots to the equation. There's lots of other factoring methods besides easy trinomial. Here's one that's a hard trinomial question. So I'm going to use my hard trinomial factoring technique here. The product, 2 times 5 is 10. The sum is this number in the middle, 11. And the numbers to consider are 1 times 10 and 2 times 5. Those are the two pairs that multiply together to give you 10. And 1 and 10 are the numbers that are going to add to give you 11. So I have 2t squared plus 10t plus 1t plus 5 equals 0. I've decomposed the middle terms using the two magic numbers, and then I can common factor out a 2t from the first ones and a 1 from the second ones, and I create that warm and fuzzy feeling. So t plus 5 times 2t plus 1 equals 0. Now it's factored. One factor times another equals 0. So either t plus 5 equals 0, meaning t equals -5, or 2t plus 1 equals 0. 2t equals -1, t equals -1/2. So either of these numbers substituted into the original equation for t will make it equal to 0. Two solutions to this quadratic equation. This one right here, I want you to notice it doesn't have a number at the end, like a +5 or something like that at the end. So it has the a term and the b term. It's like this: ax squared plus bx equals 0. No c right here. And when it's like that, you always use common factoring. So from this, you can always pull out one of the variables there, a y, and you're left with y minus 3 equals 0. So these ones are a lot easier, but you need to recognize them. So y equals 0 or y minus 3 equals 0. So y equals 0 is already solved. Transpose the -3 to a +3, and y equals 3. So these two numbers are the solutions to this equation. For example, 3 squared is 9, minus 3 times 3 9 minus 9 equals 0. Or 0 squared is 0, minus 3 times 0 also equals 0. These are the solutions to that equation. The next question isn't set equal to 0, so you need to transpose the 20 to make it so. So you've got n squared plus 4 minus 20 equals 0. N squared minus 16 equals 0. In this quadratic equation, there's no b term. Ax squared plus bx plus c equals 0. It looks just like this. There's no x term in the middle, or in this case, no n term in the middle. So this one is solved a little bit differently. We're going to solve it like a grade 9 equation. We're going to transpose the 16, and then we're going to say n is equal to get rid of a square on this side, we're going to square root the other side, and we're going to write plus or minus the square root of 16. Plus or minus 4. So n squared equals 16. Some number squared equals 16, so a square on this side becomes a square root on the other. And remember, there are two square roots. You can either say positive 4 squared is 16, or negative 4 times negative 4 also gives you 16. This one we need to solve as well. This is question 8c from your homework, so we're going to rearrange it like this. 3p squared plus 8p. We're going to transpose the 2p, and it's going to become a minus 2p minus 9 equals 0. 3p squared plus 6p, putting these two terms together, minus 9 equals 0. Now it's a quadratic equation equal to 0, and it's in the form ax squared plus bx plus c equals 0 in that proper order. So I notice with this one, it looks like a hard trinomial, but on closer inspection, you can common factor out a 3 from them. So you've got 3p squared plus 2p minus 3 equals 0. And now this is an easy trinomial. 3 times so I'm solving it like an easy trinomial. What numbers multiply together to give you negative 3 and add to give you positive 2? The numbers would be positive 3 and negative 1. So we have two factors equaling 0. This is just a number in front. The number 3 can't be 0. 3 equals 3, it can't equal 0. But p plus 3 equals 0 when p equals negative 3. Or p minus 1 equals 0 when p equals 1. So we have two solutions to that equation. 3 more examples and then we're done. Here is question 9, and what makes this one a little bit harder is that it has a denominator. So we're going to go back to our skills in solving grade 9 equations. We want to eliminate the denominator by multiplying everything by 4. So I'm going to put a 4 here, a 4 here, a 4 here, and a 4 here. By multiplying everything by 4, you'll see what happens in the first term. 4 divided by 4 cancels and leaves you with 1. So now our new equation is 1 times x squared gives you x squared minus 4x minus 12, and 4 times 0 is 0. So now you've got an easy trinomial, right? We've got rid of our denominator, and this equation has the same roots as this equation. So let's do easy trinomial on this one. Or so in this particular equation, once we eliminated our denominator and created an easy trinomial, I said what numbers multiply together to give you minus 12 and add to give you minus 4. So I factored it using the easy trinomial method, and then I said each factor equal to 0. X equals 6, x equals negative 2 are the two solutions. they'll make this equation 0, they'll make that equation 0. You can check by just substituting that number in there if you like. This one is question 10C is another one with a denominator. We're going to multiply both sides by 2. And when you multiply both sides by 2, you can cancel this denominator with this one. So an equation is like a balance. If you do the same thing to both sides, they maintain their balance. So canceling these 2's, we have 3y squared plus 7 equals 10. So I'm going to set that equal to 0. Here's another equation where there's no b term, right? There's no just y term in there. It's 3y squared, no y term. So that means we're going to solve it using the method of transposing. 3y squared equals 3, dividing by the coefficient. Y squared equals 3 over 3. So y squared equals 1. And if you have y squared equals a number, then you just go to use grade 9 techniques, like a square on this side becomes a square root on the other. So y equals plus or minus square on this side, square root on the other. And the square root of 1 is 1. So there's your two solutions. My final example is question 30B that involves a lot of simplification before you get started. So let's do the simplification part in red. I'm going to use our skills that we learned in Unit 1 and our polynomials unit to simplify this out first using whatever, FOIL, or in this case, a distributive property. So let's see, we've got 2x squared minus 3x plus 4x plus 4 equals 6 plus 4x. So we've got terms all over the place. We want to rearrange them so they're equal to 0. So right here I have my x squared term, and then I have a minus 3x and a plus 4x, and I'm going to transpose this 4x to the other side and make it a minus 4x. So this 4x came over and is here. And then I have a plus 4, and then I'm going to transpose the 6. Now it equals 0. So all the terms on the left side equals 0 on the right hand side. And I think I've transposed those correctly. So now you have 2x squared minus 3x plus 4x minus 4x. Those three go together to give you minus 3x. And then 4 subtract 6. 4 subtract 6 is negative 2. And that equals 0. So I've created a hard trinomial, and I'll use the method of decomposition to solve it. 2 times negative 2 is negative 4, so a product of negative 4 and a sum of negative 3. 1 times 4, 2 times 2 are the only pairs that give you a product of 4. And I want it to be a negative 3 sum, so I need a negative 4 and a positive 1. These are my magic numbers. This is my pair. I'm going to use that in decomposition. 2x squared minus 4x plus 1x minus 2 equals 0. I use these magic numbers in here, decomposing the middle term. Common factor from the first term, from the first two terms, common factor from the second two terms. All you can take out is a 1 from these ones. And you create that warm and fuzzy feeling. X minus 2 times 2x plus 1 equals 0. So a quadratic equation, you want to have it set equal to 0, and then you factor it using all the different techniques I've shown you. And then once it's factored and set equal to 0, you just set each factor equal to 0 to get your solutions. So those are some examples from your homework. I'm going to get you to try the other ones, and we'll try to have a video chat tomorrow morning, Friday, April 17th. Hope things are going well.